अरे यार तुम 30 लोग सॉल्व कर रहे हो, फिर भी मेरी जरूरत है तुम्हें।
सर पता चले सबने गलत सॉल्व किया सर, फिर क्या करेंगे
नहीं,
सर?
अगर जहां आंसर नहीं मैच करे वहां पे हम कर लेंगे ना साथ में। मेरे पास नहीं आंसर, मतलब जस्ट टू आंसर योर क्वेश्चन मेरे पास आंसर्स नहीं है, राइट?
ओके सर।
हाँ, बिकॉज आई डोंट हैव वेरी स्ट्रॉन्ग बिलीफ के आंसर हो। But yes, you have a valid point. How would you know? So if you have any doubt, let me know. We'll take up those questions wherever there is even slightest of doubt, right?
सर गुड मॉर्निंग सर।
हाँ, अब बोल बेटा।
सर ग्रुप पे एक क्वेश्चन था, वो नहीं समझ में आया, किसी ने
क्या?
डाला था।
मैंने देखा नहीं, मैं अभी देख लेता हूँ। लेट मी जस्ट ओपन द ग्रुप व्हाइल वी आर टॉकिंग। फेज 1, एक सेकंड, लेट मी जस्ट ओपन इट एज आई एम टॉकिंग टू यू। फेज 1 अगस्त। कितना ऊपर है बेटा ये?
ज्यादा ऊपर नहीं है।
कौन से वाले क्वेश्चन की बात कर रहे हो? कैन यू हेल्प मी आउट?
एक मैं वापस भेज देता हूँ।
ये यस्टरडे, अच्छा ये जो रेड फॉन्ट में,
हाँ
उसी की बात कर रहा है क्या?
हाँ हाँ हाँ।
ओके, लेट मी जस्ट रीड इट आउट फॉर यू। मैंने देखा नहीं, आई हैव जस्ट सीन एक्चुअली। A wall-sided vessel of constant water plane area. What does it mean? That means water plane area right from keel to deck is same, right, beta? That is the meaning of water plane here. This wall-sided, okay? Has a length of 105 meters, following equally spaced ordinates. कितना गया यार? Okay. Okay, the number of ordinates is 1, 2, 3, 4, 5, 6, 7, 8. Okay, तो दो रूल लगेंगे इसमें. When floating on even keel draft of 4.5 meters, an empty compartment with transverse bulkhead ordinate is bilged. Calculate the, नहीं आपके लिए नहीं है बेटा, क्योंकि इसमें बिल्जिंग का पार्ट आ गया है, ठीक है? हालांकि
अच्छा।
हाँ, इसमें बिल्जिंग का पार्ट आ गया है, तो ये आप रहने दो इसको। बट आप इसको करना चाहो तो ऐसे कर लो, फाइंड।
नहीं चाहता, मैं बिल्कुल नहीं चाहता
नहीं
सर।
नहीं नहीं, मैं बता रहा हूँ ना तुम उसको। मैं कह रहा हूँ फाइंड द डिस्प्लेसमेंट ऑफ द शिप एट 4.5 मीटर्स एंड फाइंड इट्स टीपीसी। आप इसको चेंज कर लो क्वेश्चन को, ठीक है, अपने स्कोप में लाने के लिए। तो फिर आपको ये वॉल साइडेड और ये इश्यूज तो एड्रेस हो जाएंगे ना, अदरवाइज यू विल हैव अ टेंडेंसी टू जस्ट डंप द क्वेश्चन असाइड। You see, when I say the question is not, does not apply to you, means because of certain constraints, right? That is the bilging component, right? Otherwise, this question, the first part of the language can be retained and question can be made suitable for phase 1, right?
सर
हाँ जी
सर, इस क्वेश्चन को ऐसे करके देखा था सर। इसके जो पहले 3 कोऑर्डिनेट, जो पहले 5 कोऑर्डिनेट थे, उसको रूल नंबर 1 से सॉल्व करा, उसका एरिया निकाल लिया सर।
अच्छा,
ठीक है। और सर जो बाकी के 3 बचे थे, उसको, जो बाकी का बचा था, उसको दूसरे रूल से निकाल लिया सर।
रूल 2 से निकलेगा वो।
हाँ जी, दूसरा रूल 2 से निकाल लिया सर।
हाँ
उसके बाद सर जो एरिया जो हमारा वो 6.7 वाला ऑर्डिनेट था सर, उसके 3 ऑर्डिनेट पकड़ के ना उसका वो निकाल लिया एरिया, सिर्फ उसी एरिया का जो बिल्ज हुआ, सिर्फ उसी का रूल नंबर 3 से।
बेटा अगर दो ऑर्डिनेट 6.7 6.7 है ना,
हाँ जी।
करेक्ट? तो
मैंने
तुम,
सर
हाँ बोलो सॉरी, हाँ बोलो।
मैंने सर 6.7 6.7 मतलब 13.4 13.4 और जो 11.2 है, इनको पकड़ के सर 13.4 वाला एरिया निकाल लिया, सिर्फ सेपरेट वो एक। ठीक है सर। और सर फिर उस एरिया का वॉल्यूम निकाल लिया जो बिल्ज हुआ, मतलब उसका एरिया आ गया था, उसको 4.5 से मल्टीप्लाई करके उसका वॉल्यूम निकाल लिया।
ठीक है
सर। फिर इंक्रीज इन ड्राफ्ट ना, जैसे वॉल्यूम जो जिस एरिया का लॉस्ट हुआ उसको डिवाइडेड बाय सारा एरिया माइनस छोटे वाला एरिया।
वो नहीं होगा ना बेटा। जैसे जैसे पानी आएगा तो पानी उस होल्ड में भी बढ़ता जाएगा ना जिसमें पानी आ रहा है। अभी तुमने 4.5 लिया शुरू में तो, राइट?
हाँ जी।
बट जैसे जैसे ड्राफ्ट 4.6 होगा तो वहाँ पानी का लेवल 4.6 हो जाएगा। ड्राफ्ट 4.7 होगा तो वहाँ ड्राफ्ट पानी का लेवल 4.7 हो जाएगा। साउंडिंग करेक्ट?
इससे जैसे किया था तो इसका आंसर तो सेम आ गया था सर, लेकिन
बेटा मैं आप इसको बेसिकली तो मैं फेज 2 में आई डोंट वांट टू अननेसेसरली यूज सम लैंग्वेजेस लाइक लॉस्ट बुoyancy मेथड, एडेड वेट मेथड, ठीक है? राइट, व्हाट आई एम सेइंग इज व्हाट यू शुड बेसिकली डू हियर इज, इसी क्वेश्चन का जैसे तुमने एरिया निकाला है, राइट? अब मैं तुम्हें कहूँ कि तुमने पूरा वाटर प्लेन एरिया निकाले जो भी रूल कॉम्बिनेशन लगाया, अब मैं तुम कहता हूँ व्हाट इज द डिस्प्लेसमेंट एट 4.5 मीटर्स, तो तुम उस एरिया को 4.5 से मल्टीप्लाई कर दोगे, दैट विल बी द अंडर वाटर वॉल्यूम मल्टीप्लाइड बाय डेंसिटी विल बी द डिस्प्लेसमेंट, राइट?
यस सर।
और अगर मैं कहूँ टीपीसी, तो वो एरिया को 100 से डिवाइड करके डेंसिटी ऑफ वाटर से मल्टीप्लाई कर दोगे, दैट विल बी द टीपीसी।
टीपीसी आ जाएगा, हाँ जी सर।
राइट, सो let us only keep it to the scope of within the scope of phase 1 what we have learned. हम मोमेंट ऑफ इनर्शिया कर नहीं रहे हैं, हम फेज 2 का बिल्जिंग कर नहीं रहे हैं, तो लीव इट आउट, राइट?
फेज 2 का ठीक है सर, ठीक है।
मतलब हाँ, दिस बिल्जिंग इज नॉट बीइंग कवर्ड हियर ना बेटा।
ओके ठीक है।
हाँ ओके ठीक है। Okay guys, as I had told you last time also, I've given you this week for you to basically brush up your past concept of kg, FSC, and little bit of free surface correction, FSM, kg, all those things. And another thing I had requested you was to close out the Simpson's rules, so that next week onwards we can get going with the GZ curve. Okay, and to utilize this window, whatever couple of sessions we have, we'll run through some of the topics. And as you already know that two topics have already been covered. That was the watertight bulkhead and watertight doors. Then we have the third topic we can take is the corrosion, which I don't think there is much for me to teach actually, because this is one part which you have already been dealing with on the ships. You have been studying about it right from your PC in some form or the other, dealing with it on ship. So there is nothing much that I really need to tell you here, but it's always good to go through so that if questions are there, you are able to answer the questions. So corrosion, after corrosion हमारा एक theory का वो रह जाएगा part, that is your harmonized survey system. Other than harmonized survey system, everything else would have been taken care of. Okay, so now we can go ahead with this corrosion part and see. I'll just take you through the slides. I'll read them. If you have anything to ask, please ask them because they are practically self-explanatory. Okay, what is corrosion? Corrosion is basically deterioration of the metal. What metal are we talking about? We are talking of steel, be it mild steel or any other steel which is susceptible to corrosion. So that is the steel we are talking about. Now, is corrosion a physical reaction, physical phenomena, or a chemical reaction? It's a chemical reaction. What does the metal react with? It reacts with its surrounding. Why does it react? It reacts because when the metal is extracted from the earth, from the below the earth surface during mining, the metal is recovered in a certain form called as its ore. चाहे वो आयरन ore हो या बॉक्साइट हो या कुछ भी हो, it's in its ore form. Ore form means जिस form में वो आता है, that is the form in which the metal tends to stabilize. That is its stable form, right? अब उसको आपने प्योरिफिकेशन के चक्कर में आपने उसके साथ छेड़छाड़ किया, बिकॉज आपने आयरन ओर से ओर बनाया, माइल्ड स्टील को की कोई कॉम्पोजिशन की, सो आपने उसका जो नेचुरल स्टेबल स्टेट था, यू हैव ट्राइड डिस्टर्बिंग दैट टू अचीव योर ओन एंड रिजल्ट्स और एंड गोल्स, व्हाटएवर मे बी द गोल. अब आपने उसको छेड़छाड़ करके यू हैव ब्रॉट इट टू अ सर्टेन फॉर्म व्हिच इज मे बी मोर यूजफुल टू यू, दैट्स परफेक्टली फाइन, but it is definitely not in its stable form or its natural form. And what is the tendency? Tendency of everything, including the human beings, is to return to their basic natural form. I'll give a very simple example, beta. Some of us are hardcore vegetarians at home. Fine. When we go on the ships, we become non-vegetarians. And you'll find, barring few exceptions would always be there. barring few exceptions, most of the people who are basically vegetarians at home, when they get an opportunity, they usually automatically revert back to vegetarian food, and vice versa. If somebody is basically a non-vegetarian and has switched over to vegetarian for some time, would have carving at times to get back to non-vegetarian food. So why? Because you have a tendency to go back to your natural self, whatever you have been brought about, were born with, or the surroundings in which you are brought up, they have become part of your system. इसी तरह जो और था, आयरन और या जो भी मेटल का और था, वो उसकी नेचुरल स्टेबल स्टेट है. आपने उसके साथ छेड़खानी की, you purified it, got something which you wanted to use, that's fair, but the moment it gets an opportunity, it will tend to go back to its natural state, and that is the root cause of this entire problem of corrosion that we face. There is a natural tendency for nearly all metals to react with the environment. The result of this reaction is that the creation of a corrosion product that is generally a substance of very similar chemical composition to the original mineral from which the metal was produced. जहां से natural form में metal exist करता था, tendency is to go to very close or maybe the same form in which it was initially extracted. In the most common use of the word, this means the electrochemical oxidation of metals in reaction with oxidants such as oxygen. In simple form, what is corrosion? Corrosion is oxidation of iron. So oxidation of iron and iron getting converted to ferric oxide and ferrous oxide is what is corrosion. Then there is a similar term called as erosion. Erosion also, corrosion में क्या होता है? There is a wastage of the material, metal. Erosion में भी क्या होता है? There is wastage of metal. But erosion में the wastage of the metal is because of a physical impact. उस पे आपने कोई force लगी, impingement हुआ, कुछ impurities ना आके उस पर अटैक किया, या स्पीड से पानी फ्लो कर रहा था, जैसे रिवर बैंक पे अगर इरोजन होता है, जो सैंड लगाए, वो जो बोल्डर्स लगाए होते हैं, दे इरोड. व्हाई? बिकॉज द फ्लोइंग वाटर टेंड्स टू इरोड द बोल्डर्स व्हिच आर पुट ऑन द साइड. सो इरोजन में भी वेस्टेज है, कोरोजन में भी वेस्टेज है. यहां तक तो दोनों सेम है, लेकिन द कॉज ऑफ वेस्टेज इज डिफरेंट. इन कोरोजन इट्स chemical reaction, electrochemical reaction. In erosion, it's a physical impact which leads to wastage. However, when erosion takes place, as far as metal is concerned, it tends to expose the metal to its environment, and hence erosion can be a trigger to corrosion. But there are two distinct terms. One is erosion and the other is corrosion. Erosion is essentially a mechanical action and can occur in impingement attack by air bubbles entrapped in the flow of water and striking the metal surface may erode away any protective film that may be present locally. Example, seawater discharges from the hull are a particular case, the effects being worse if the warm water is being discharged. So that is the impingement attack by the air bubbles, which act like solid particles when they hit the surface. Cavitation damage that is associated with formation of bubbles associated with a rapidly flowing liquid and subsequent bursting of those bubbles called as implosion. The energy released during implosion causes the pitting or the erosion of the metal. So the causes of erosion could be impingement attack. Example could be an impingement attack by the air bubbles, or cavitation damage by the implosion of the air bubbles which are created. However, erosion, which is a mechanical action, as we have said on top, leading to damage of protective coating. Once the coating is damaged and the metal is exposed to the environment, obviously it can set the corrosion. So, but it does not mean if erosion has led to corrosion does not mean erosion and corrosion are the same things. They remain two distinct terms. Is that clear, guys? Okay, beta, ab tak?
Yes, sir.
Okay. Highlight ball pen. Highlight arrow. चलो arrow ही ले लेते हैं. ठीक. Okay. Then, like we have the fire triangle now, they call as a fire quadrilateral also. So like we have fire triangle that you have to have 2-3 things which need to be there for fire to take place. Likewise, for corrosion to take place, obviously there are certain things or certain contributors to the corrosion which need to be there, failing which the corrosion cannot happen. So for corrosion to occur, there are 3 things which are required, and that's why these 3 things being 3 things required for corrosion, they are referred to as corrosion triangle. Corrosion to take place, there must be an anode, a cathode, and an electrolyte joined by an external current circuit. So there has to be an electrolytic cell which has to be formed. So there have to be 2 distinct metals, one acting as anode of the cell, other acting as the cathode of the cell. They need to be connected through an electrolyte. अगर आप अपनी बैटरीज को घर में देखो जो इन्वर्टर वगैरह वाली आती हैं, आप पानी डालते हो, that is the electrolyte. उसके ऊपर प्लस माइनस, plus is the anode, minus is the cathode, and these are the 2 electrodes immersed in the electrolyte. So if we treat it like a triangle, then you have this triangle called as the corrosion triangle, in which you should have something acting as anode, something as acting as cathode, and you need to have the electrolyte. If the cell is not formed, corrosion cannot take place. Now, if this generic stuff is seen in context of the marine environment, then what are the 3 things which basically facilitate the phenomena of corrosion are? There has to be some metal which is susceptible to corrosion like steel, and that is available in abundance on our ships. Then there has to be air from which, or a source of oxygen. Why? Because we said corrosion is nothing but oxidation of the metal. So for oxidation, oxygen supply is must, and oxygen is obviously available in the atmosphere. So other is the availability of air or the oxygen, whatever you want to say. The third is the moisture, which has to be there. It acts as the electrolyte. The moisture provides the conducive environment for corrosion to take place, and this moisture is also in ample quantities. The air is moist, and then you have seawater surrounding the ship. You have the sea shipping on deck, so moisture is also in abundance. These are the 3 elements of this corrosion triangle as far as marine corrosion part is concerned, but primarily they are cathode, anode, and electrolyte. For marine considerations, the corrosion triangle comprises of what? It comprises of the metal, of some metal which is susceptible to or prone to corrosion, source of oxygen for the purpose of oxidation, and the seawater to form the electrolyte or the moisture that forms the electrolyte for conduction of current. So that's how this basically thing takes place. Now तुम ये कहोगे कि सर ये अब इसमें आपने इलेक्ट्रोलाइट भी बोल दिया, आपने मेटल बोला है, अब इसमें एनोड कैथोड तो आपने बताया नहीं. अब कई बार सेम मेटल के कुछ पार्ट एनोड कैथोड का रोल प्ले करेंगे, कई बार हमारे पास 2 अलग अलग मेटल आसपास में होंगे. दे विल बिटवीन द 2, one will be acting as anode, the other would be acting as cathode. Types of corrosion, ये बेटा तुम्हारे ना सिलेबस से लिया गया. अगर सिलेबस में लिखा है डिस्कस द टाइप्स ऑफ कोरोजन, तो यहाँ पे उठा के टाइप्स ऑफ कोरोजन डल गया है. That's how these slides have been prepared. Okay. Atmospheric corrosion is the corrosion of metal surface because of their exposure to humid atmospheric conditions. So जब आपका मान लो कोई मेटल है, आपने यहाँ भी अगर ऑन लैंड ऑल्सो आपने कोई मेटल जो है रखा हुआ है, what is in touch with? It is not in touch with water per se. It is in touch with the atmosphere. And you see that if you put a absolutely bare metal iron, after some time it will have that yellowish stain on it. That is, we all know, is the rust. That is because of the atmosphere coming in contact with the surface, and that is called as the atmospheric corrosion. Corrosion due to immersion. So now as far as the ship is concerned, some part of the ship are always underwater. Some parts are sometime above water, sometimes underwater, depending on the draft of the ship. Now, in these parts, whether they are intermittently inside water or they're permanently inside water, again, you have the corrosion which forms on these parts. Why? Because the water acts as the electrolyte and you have the formation of electrolytic cell. Then bimetallic or galvanic corrosion. देखिए, basically galvanic corrosion is where galvanic cell is formed. So कोई भी corrosion होगा तो वो उसमें galvanic cell तो form होगा ही. Why a bimetallic is being spoken separately here is that on the ship there are many places where different metals are located in the close proximity. Like you have an alloy propeller close to the ship, steel hull of the ship. You may have the aluminium superstructure being connected to the steel hull of the ship. So that is where the two different metals get connected. And obviously when two metals get connected, come in the close proximity, it becomes a bimetallic corrosion. Although all corrosion is basically galvanic, the term galvanic corrosion is usually applied when metals form a corrosion cell. Amongst the more common bimetallic corrosion cell problems in the ship's hull are those formed by mild steel hull is one metal, with the bronze or nickel alloy propeller forming the other metal. So in the stern part closer to the propeller, you can expect bimetallic corrosion ke chances to be higher. Attachment of the bronze and aluminium alloy fittings. So if you have any fittings of aluminium or bronze which are being fitted to the steel hull, mild steel hull, obviously then you are creating the risk of bimetallic corrosion. Where aluminium superstructures are introduced, the attachment of these steel hull and the fitting of the steel equipment to the superstructure could be another area of bimetallic corrosion. Then you have guys something called as stress corrosion. देखिए अब तक बायोमेटेलिक भी आप समझ गए, एटमॉस्फेयर के साथ में भी हो गए. अब ये स्ट्रेस कोरोजन क्या होता है? स्ट्रेस कोरोजन ये होता है कि अगर आपने किसी स्टील की प्लेट को कोल्ड फ्लेंजिंग की है, आपने उस पर कोल्ड वर्क किया, उसकी हैमरिंग की है, तो ये जो आपने उस पर फोर्सेस अप्लाई की हैं वो दे टेंड टू ऑल्टर द कॉम्पोजिशन ऑफ द स्टील. जो उस प्रोसेस से पहले पूरी की पूरी पीस होमोजीनियस थी कॉम्पोजिशन में, now tends to become heterogeneous with some changes in the composition in the areas which have been hammered or where these forces have been applied. So अब आपने क्या किया है, तो वो स्टील ही पूरा सेम माइल्ड स्टील है, लेकिन आपके जो एक्शन थे उसके कारण उसकी जो होमोजेनिटी है वो खत्म हो गई और वो हेट्रोजीनियस हो गया. दैट मीन्स उसके कुछ पैचेस अलग कॉम्पोजिशन के हो गए स्लाइटली, and that means now the same metal which to you and me is only one mild steel, but its different portions behave differently as if they are two different metals which you can't make out with your naked eye. And obviously then that sets in the reason for that being the stress induced, and therefore the corrosion because of this is called as the stress corrosion. Corrosion and subsequent failure associated with varying forms of applied stress is not uncommon in marine structures. Internal stresses produced by non-uniform cold working like bending, shearing, punching, riveting, etc. are more dangerous than applied stresses. Stress induced by rivets and bolts and by press and shrink fits can also be classified as internal stresses. Stress tends to set in heterogeneity in the metal composition. वो जो उसकी homogeneity को है disturb कर देता है, and it tends to set in heterogeneity, leading to setting up of galvanic cells. For example, localized corrosion often evident at the cold flanged brackets. ये जो बेटा नीचे में हमने जो ब्रैकेट्स पढ़े थे ना, इसमें जब हम बल्कहेड पढ़ रहे थे कि ब्रैकेट के साथ इट इज कनेक्टेड टू द टैंक टॉप और मे बी डायरेक्टली वेल्डेड दोस फ्रेम्स और स्टिफनर्स. वो ब्रैकेट किस तरह के होते हैं? आपने देखा होगा ब्रैकेट को आगे प्लेट को बेंड किया होता है, राइट? तो उसको बेंडिंग कैसे की जाती है? दैट्स कोल्ड बेंडिंग. इट्स नॉट हीट करके और उसको मतलब नॉट मोल्ड, इट्स नॉट बेसिकली कास्ट दैट वे. It's cold bending. If it's cold bending, called as cold flanging, then obviously you can have those as the areas where stresses get locked in, and those could be the places which will have higher risk of stress corrosion. So, are the types of corrosion clear, beta? Stress corrosion, bimetallic corrosion, and atmospheric corrosion, right? Okay, bhai?
Yes, sir.
Okay. Then what are corrosion cells and how do they get basically formed? Now, कोई हमने कहा था कि कोई भी metal, it has a tendency to return to its natural state. So when it is trying to return to its original state or making an effort, rather, whether it can return or not is a secondary issue. But when it is attempting to return to its natural state, it has to release energy or release the electrons. At ordinary temperatures in aqueous solution, aqueous means water solutions, the transformation of a metal atom into a mineral molecule occurs as the metal passes into the solution. क्या होगा? जो एनोड होगी, the metal which is acting as anode, उसके जो atoms हैं, they are dissolved into the electrolyte, and as they are dissolved, these atoms are converted into iron, releasing the electrons. So that is what happens at the cathode. During this process, the atom loses one or more electrons and becomes an ion. That is, it becomes electrically charged atom. So it's already in the solution and now it's electrically charged atom with production of electric current, the released energy. This reaction may only occur if the electron acceptor is present at the in the aqueous solution. So अब ये देखिए इलेक्ट्रॉन उसने रिलीज किए, बट वो रिलीज क्यों कर रहा है? बिकॉज देयर इज some other at the other end of it, there is another metal which is acting as the cathode and is ready to receive the electron. तो वो कैथोड पे क्या होता है? ये जो ये आयन बना मेटल का और इलेक्ट्रॉन्स, दे आर ऑल बेसिकली ड्रॉन टूवर्ड्स द कैथोड. तो अब क्या हुआ? एनोड से जो मेटल के एटम्स जो पानी इसमें एक्वस सॉल्यूशन में इलेक्ट्रोलाइट में they slip into electrolyte or dissolve into electrolyte, whatever you want to say, means what? That means anode is being eaten up. Anode is being eaten up. Thus, any corrosion reaction is always accompanied by flow of electricity from one metallic area to another through the solution called as electrolyte. If electrolyte is non-conducting, then this transmission cannot take place. So what is an electrolyte? Electrolyte is a conducting solution, a solution which can conduct or which conducts electricity or allows the electricity to flow through it. Such a solution is referred to as electrolyte, and because of its high salt content, seawater is a good electrolyte. Because of the salinity of the seawater, because of the presence of salt in the water as sodium ions and chloride ions, the salt water is a good electrolyte and allows the electrons to be transmitted or the current to pass through it. ये देखिए बेटा यहाँ पर ये हमारी एक नॉर्मल गैल्वेनाइक सेल का लेआउट है, जैसे आपकी बैटरी में होता है बेटा। ये एक तरह से समझो, ये बैटरी की केसिंग होगी जो आपको बंद दिखाई देती है। अंदर में एक आपकी एनोड है और एक आपकी कैथोड है। ये आपकी इलेक्ट्रोलाइट है और एक्सटर्नली ये कैथोड और एनोड कनेक्टेड होती हैं, ठीक है। अब इसमें क्या होता है बेटा, यहां से जो भी इलेक्ट्रॉन्स रिलीज होंगे और जो आयंस रिलीज होंगे, the electrons flow from anode to cathode in the solution. So inside the cell, the current flows from anode to cathode. But in the external circuit, the extra electrons are basically passed through this back to the anode. So this is how this current flows in a battery. So this is the construction of a battery where the current flows because of this external connection out here. So this is how your batteries actually work. One electrode acting as anode, another electrode acting as cathode. ये तो हमारी बैटरी की गैल्वेनाइक सेल की कंस्ट्रक्शन है। लेकिन ये सेल अगर शिप पे डेक पे देखो कैसे बनेगा, ये देखो, ये शिप की डेक थी पूरी एक, इट वाज मे बी पेंटेड प्रॉपरली, ओके। फॉर वॉट एवर रीजन यहां पर पेंट आपका डैमेज हो गया। अब जब ये पेंट आपका डैमेज हो गया तो ये जो पार्ट है सेल यहां पर जब पेंट से कवर्ड है, और ये जो पार्ट आपका है जो एक्सपोज्ड है, दे एक्ट एज टू डिफरेंट मेटल्स। एंड व्हाट हैपेंस, दिस एक्सपोज्ड पार्ट टेंड्स टू एक्ट एज एनोड। सो यहां से योर मेटल इज ईटन अप एंड वो यहां से निकल के आपको साइड में जमा होता दिखाई देगा एंड यहां पर आपकी मेटल में पिटिंग हो जाएगी। This is where the pitting takes place at the anode, and you have a galvanic cell formed on the same metal with no distinct electrodes. यहाँ तो दो इलेक्ट्रोड बड़ी डिस्टिंक्ट थी, एक एनोड थी एक कैथोड थी। यहाँ पर the different parts of the same plate are acting as anode and cathode, and one part acting as anode gets eaten up by a formation of the galvanic cell. So this basically gets eaten up from here. You see in this case क्या हुआ, ये जब जिसको यहां पर जिसने एनोड एक्ट करना था, इसमें क्या होगा, ये क्या था आयरन, दिस आयरन dissolves into the electrolyte. What is the electrolyte in this case? The sea water. When it passes in, not dissolve, when it passes into the electrolyte, what does it break into? It breaks into iron, ions of iron. Ions of iron are called as ferrous ion, Fe2 plus, and ferric ion, Fe3 plus. And in the process of becoming ferric and ferrous ions, they release electrons. Now these electrons and these ferric ferrous ions are basically attracted towards the cathode, and at the cathode what happens is the oxygen and the hydrogen, they combine with these electrons which have been received from the anode through the electrolyte, and that gets converted into hydroxyl ion or OH ion, hydroxyl ion. This hydroxyl ion reacts with the ferric ferrous ions which have come towards the cathode, and you get ferric oxide and ferrous oxide formed at the cathode. And this ferric oxide and ferrous oxide at the cathode is nothing but your rust. In this case, this orangish stuff here is the rust. Where has it come from? It is because of this metal being eaten up, its oxide being deposited here as the rust. So beta mota mota ye clear ho gaya tumhe, formation of corrosion cell on a single metal sheet like deck or something?
Yes, sir.
Okay. Oxidation of the elemental iron occurs at the anode. I have already said oxidation happens at the anode. First, the elemental iron breaks down and leaves the anode, so pits form in the surface of the anode. The electrons from the breakdown of the elemental iron flow through the electrolyte to the cathode. This is what I just explained. There they leave the metal. The electrons leave the metal and enter the water by reacting with hydrogen ions, forming the hydrogen gas. and of course the hydroxyl ion, and they react with ferric ferrous ions to give you the ferric oxide and ferrous oxide. अब ये जो metals हैं, एक एनोड और एक कैथोड जो बनते हैं, what decides as to which one would be anode, which one would be cathode, और इन दोनों के बीच में रिएक्शन स्लो होगी, बहुत तेज होगी, मॉडरेट होगी या बिल्कुल नहीं होगी? What determines this rate of reaction between these two different metals? Number one, what determines इनमें से एनोड कौन सा होगा, कैथोड कौन सा होगा, और दूसरा इन दोनों के बीच में रिएक्शन का रेट क्या होगा? These two things are determined by what we call as the galvanic series. What is galvanic series? Galvanic series is a list of metals put down in a certain order based on their nobility, that means their resistance to corrosion. ठीक है, so जितना वो metal ज्यादा noble होगा उस वो galvanic series में एक end पे होगा, जितना वो ज्यादा susceptible होगा corrosion के वो दूसरे end पे होगा. So there is a list of metals which has been made. So when two metals are submerged in an electrolyte while electrically connected, the less noble one will experience galvanic corrosion and more noble will be tending to act as the cathode because it is more stable and it's not likely to compare to the other one. The rate of corrosion is also determined by the electrolyte and the difference in nobility. अब rate of corrosion will depend on the electrolyte. If electrolyte is highly conductive, rate of corrosion will be more. If it's less conductive, because electrons have to flow through it. So if it's less conducting, then corrosion will be less. On the other hand, it will also depend upon कि anode और cathode की nobility में difference कितना है. It is like this, beta. If there are two bodies, one is very hot, one is very cold. You bring them in touch, the rate of flow of heat will be very high. Why? Because the temperature difference is quite rapid, right? वही चीज अगर इनके temperature difference कम हो जाएगा, it is like nobility in the series being very close to each other, the heat flow rate will be much lesser. दूसरा, अगर इनमें से एक non conductor of heat हो, temperature high हो, उसको touch करोगे तो within the metal the heat is not flowing that rapidly, so obviously that will become as a deterrent for the heat sharing or heat flow from one metal to other. So exactly the same way we have the galvanic series. The difference can be measured as a difference in voltage potential. Galvanic reaction is the principle upon which batteries are obviously made and based. The following is the galvanic series for stagnant seawater. Please pay attention. It is only for seawater which is stagnant. If it is moving, salinity is changed, temperature is changed, environment is changed, the series can experience a change. But this is the series for stagnant seawater. What does it mean? That the metals at this end of it, they are most susceptible to corrosion. That means these metals are less noble. That means out of this list, magnesium and its alloy are the least noble one. That means अगर वो किसी भी इन मेटल के साथ अगर पेयरिंग बनाएंगे तो magnesium और उसका alloy will act as the anode and would be suffering from experiencing corrosion. Next in the list is zinc and its alloys, and like this you can see. And as you come to the other end of this spectrum, you have least susceptible metals to corrosion, corrosive attack, and therefore these are more noble. So these are more noble. That means अगर platinum जो इनमें से किसी भी मेटल के साथ अगर पेयरिंग करेगा तो प्लेटिनम कैथोड ही बनेगा. अगर गोल्ड और प्लेटिनम की पेयरिंग होगी तो गोल्ड विल बी एनोड, प्लेटिनम विल बी कैथोड. लेकिन अगर गोल्ड सिल्वर की होगी तो गोल्ड विल बी नाउ कैथोड, सिल्वर विल बी एनोड. सो डिपेंडिंग ऑन हाउ दे आर प्लेस्ड इन दिस गैल्वेनाइक सीरीज, they will take over the respective role of cathode and anode. The order of these metals in the series may change if the environment is altered. Now, with this galvanic series having been done, what are the factors that affect the rate of corrosion? We need to know what are the factors that affect the rate of corrosion. Now one is the temperature, beta. Rate of corrosion increases with temperature. So if higher the temperature, greater would be the rate of corrosion. Say everything remaining same, obviously. That means two metals, anode, cathode remaining same, electrolyte remaining same, all factors remaining same, but for temperature. So everything remaining same, higher the temperature, greater the rate of corrosion. Moisture, obviously, I don't think that needs to be even read out. It's greater the moisture, greater the corrosion, everything else remaining common or same. pH value decides whether a given electrolyte is acidic in nature or it is alkaline. अगर आपको स्कूल से याद हो, pH values 0 to 14 assign होती हैं. 7 is supposed to be neutral. 0 to 7 is acidic. 7 to 14 are alkaline. Okay, so less pH means the solution tends to be acidic, and if it is acidic, the corrosion will be higher. Nature of electrolyte. So obviously, if electrolyte is highly conducting, it will add to corrosion rate. If it's less conducting, it will be a deterrent for corrosion. So presence of salts in the electrolyte increase the rate of corrosion. Presence of impurities in atmosphere. This we have all experienced. Atmospheric corrosion जो है, it's higher in industrial areas than in open areas. Why? Because you have more gases or impurities like hydrogen sulfide, carbon dioxide, sulfur oxide in the industrial areas, which add to this nuisance of atmospheric corrosion. So we have these factors affecting the rate of corrosion, that is temperature. Beta ye sare ke sare are based on your syllabus, so that's I would like to just reiterate that. So temperature, moisture, pH value, nature of electrolyte, presence of impurities in the atmosphere. So they all determine the factors affecting rate of corrosion. कहाँ तक पहुंच गए हम, कितने सेल पे भाई? हम आगे 14 पे हमारे हैं, 52 कुछ और कर लेते हैं, अभी कुछ और कर लेते हैं before we slip into the break. Let's do some more. Now corrosion control is very simple, beta. How corrosion happens, what leads to corrosion, then obviously you know what is to be done to control the corrosion. What is to be done? You need to basically break the triangle, corrosion triangle. And if the corrosion triangle is disrupted, corrosion will be under control. The control of corrosion may be achieved by preventing formation of the corrosion triangle, that is the galvanic cell. आप सेल मत बनने दो, आपका corrosion नहीं होगा. दूसरा, if you cannot prevent completely the formation of galvanic cell, at least to control the rate of corrosion, you can see that the galvanic cell is formed on the basis of galvanic series, so that the potential difference between the anode and cathode is not too high. That means अगर galvanic series में दोनों के दोनों एक दूसरे के पास होंगे, तो obviously corrosion rate will be controlled. It will not be eliminated, but it will be controlled. दोनों में फर्क देखिए बेटा. First question part में कहता preventing the formation. He wants to zero down. In the second, he says if you can't zero down, at least you can use the knowledge of galvanic cell to control the rate of corrosion. So understand the difference between the 2 points. Accordingly, the corrosion control may be achieved through. So this is the basic underlying principle based on which corrosion is to be controlled. And how can this be achieved then? Actually on chip. One is by taking due consideration of bimetallic joints. हमने कहा था गैल्वेनाइक सेल बनने के ज्यादा चांसेस कहाँ हैं, जहां पे दो डिफरेंट मेटल्स साथ में इलेक्ट्रोलाइट में हो शिप पे, जैसे कि इन द विसिनिटी ऑफ द प्रोपेलर, या जहां पे आपका ये एल्यूमिनियम या एलॉय स्ट्रक्चर्स आके एमएस स्ट्रक्चर से कनेक्ट होती हैं. दोज आर द एरियाज. सो वहां पर उन जॉइंट्स को यू विल हैव टू टेक केयर कि वो जो जॉइंट्स हैं दे आर एबल टू इंसुलेट द टू मेटल्स एंड दे डोंट अलाउ द करंट टू पास थ्रू टू द टू. प्रोटेक्शन, दैट मीन्स हम मेटल की प्रोटेक्शन करें. कैसे करें? या तो उसको सैक्रिफिशियल एनोड में सिस्टम से करें, अपने वाले जो मेटल हमें चाहिए उसको बचा कर रखें, या इम्प्रेस से करें. सो प्रोटेक्शन ऑफ द मेटल. and last is application of protective coating, that is paints. So basically last वाले को भी तुम protection कह सकते हो, but उसको अलग से डाल दिया because processes are different. So you can do any of these three things based on the situation, and that will help you in control of corrosion. How do we take care of the bimetallic joints? You can see in these diagrams, beta, how the bimetallic joints, the corrosion and the bimetallic joints can be prevented. ये देखिए, यहाँ पर ये आपकी एल्यूमिनियम स्ट्रक्चर है, ये माइल्ड स्टील से इसको आपने रिवेट करना है या आपने बोल्ट लगाने हैं. आपने क्या किया, इन दोनों के बीच में आपने नियोप्रीन का इंसुलेटेड गैस्केट डाल दिया. इस बोल्ट के चारों तरफ आपने एक स्लीव डाल दी नियोप्रीन की, वो भी एक इंसुलेटेड, सो बोल्ट इज आल्सो नॉट इन टच विद एनी ऑफ दीज स्ट्रक्चर्स, राइट. और इससे आपने क्या कर दिया कि इन दोनों मेटल्स को सेपरेट कर दिया, ऊपर से आपने इनको सील कर दिया ताकि इनके बीच में पानी ना जाए. एंड आई एम श्योर यू विल एग्री that if this sort of arrangement is adopted, you have prevented a formation of the galvanic cell when these two different metals are in close proximity, right beta? Yes or no? Can you see this first diagram? I think it's pretty clear. ये जो dark black है, that is the insulated gasket, right? ये वाला, ठीक है भाई. और भाई लोगों सुन रहे हो, सो गए हो?
सुन रहे हो,
चलो बहुत बढ़िया.
सर.
दूसरे वाल,
ये जो बायोमेट्रिक जॉइंट्स का कुछ एग्जांपल?
हाँ क्या हुआ
सर, इसका कोई एग्जांपल होगा क्या बायोमेट्रिक जॉइंट्स क्या?
ये एग्जांपल ही तो है,
मतलब प्रैक्टिकल शिप में की.
हाँ तो शिप का ही तो प्रैक्टिकल है बेटा. ये क्या लिखा है, अगर एल्यूमिनियम की सुपरस्ट्रक्चर हो तुम्हारी बाय चांस, राइट, अगर एल्यूमिनियम की सुपरस्ट्रक्चर हो, उसको तुम मेन डेक के पास लाके एमएस की स्ट्रक्चर से आपको उसको कनेक्ट करना हो, तो दैट बिकम्स एन एग्जांपल फॉर बायोमेटालिक कनेक्शंस, राइट बेटा?
ओके
ओके, सो दिस इज एग्जांपल ऑफ दैट टाइप ना. क्योंकि अब आप कहोगे कि हम ये जो शिप स्ट्रक्चर है एल्यूमिनियम की क्यों बनाते हैं, सुपर स्ट्रक्चर क्यों प्रेफर करें, वो इसलिए करते हैं बिकॉज एल्यूमिनियम इज लाइट, राइट, एंड उससे क्या होगा, आपका केजी वगैरह कंट्रोल में रहता है, आपका लाइट डिस्प्लेसमेंट कंट्रोल में रहता है. सो समटाइम्स यू प्रेफर टू यूज दीज लाइटर मटेरियल्स फॉर योर सुपर स्ट्रक्चर, राइट? Okay, so wherever this will come, this sort of arrangement could be adopted. इन दो, ये दोनों सिमिलर टाइप की चीजें हैं. उस तरफ फर्क इसमें है, यहाँ पर रिवेट है, यहाँ पर नट बोल्ट था. या हम इस तरह की बॉन्डिंग कर सकते हैं बेटा. आपने क्या करना है, बेसिकली इलेक्ट्रोलिटिक सेल में क्या हो रहा है, बायोमेटालिक गैल्वेनाइक सेल में क्या हो रहा है, करंट फ्लो. करंट फ्लो क्यों हो रहा है, बिकॉज द पोटेंशियल इन द गैल्वेनाइक सीरीज, द पोटेंशियल ऑफ द एनोड एंड द कैथोड आर डिफरेंट. यहां आपने क्या कर दिया, देखिए, एल्यूमिनियम के स्ट्रक्चर को डायरेक्टली स्टील के साथ आपने कनेक्ट कर दिया और आपने एक बॉन्डिंग वायर से इन दोनों को कनेक्ट कर दिया. तो क्या हो गया, जब आपने इनको एक वायर से कनेक्ट कर दिया तो आपने इन दोनों को सेम पोटेंशियल पे ला दिया. एंड वंस दे आर एट द सेम पोटेंशियल, देन दे विल स्टॉप प्लेइंग द रोल ऑफ एनोड एंड कैथोड. सो आपने ये एक्सप्लोजन बॉन्डेड या बॉन्डिंग वायर या अर्थिंग वायर, जो भी कहो, इनको आपस में कनेक्ट कर दिया. तो उससे क्या हो जाएगा, इन दोनों की पोटेंशियल सेम हो जाएगी डिस्पाइट बीइंग डिफरेंट मेटल्स. सो ये गुड कंडक्टिंग मटेरियल वायर से आपने इन दोनों को कनेक्ट कर दिया और इसके चक्कर में आपका अब इस पे गैल्वेनाइक सेल बनने की रिस्क कम हो जाएगी. अंडरस्टूड गाइस?
यस सर.
Okay, so any of these techniques could be adopted at bimetallic joints. Then अभी दूसरा तुम्हारा जो शिप का तुम एग्जांपल कह रहे थे, वहां पे ऐसी बॉन्डिंग नहीं कर पाएंगे, वहां पर हम अडॉप्ट कर सकते हैं कैथोडिक प्रोटेक्शन. कैथोडिक प्रोटेक्शन क्या होती है बेटा, दो टाइप की होती हैं. एक तो होती है हमारी सैक्रिफिशियल एनोड, दैट मींस हम, आपने जिंक एनोड्स देखी होंगी ड्राई डॉक में, जो लोग गए हैं, लगी होती हैं. Only where metals are immersed in an electrolyte, so this will work only when the metals are immersed in an electrolyte, can the possible onset of corrosion be prevented by cathodic protection. The fundamental principle of cathodic protection is that the Anodic corrosion reactions are suppressed by application of an opposing current. अब आपने opposing current लगा दिया, वो impressed current का लगाया या आपने sacrificial type लगाई, we can see that. This superimposed direct electric current enters the metal at every point, lowering the potential of the anode metal of the local corrosion cell so that they become cathodes. I'll explain to you, don't worry. There are two main types of cathodic protection installations. Now, when I do one by one, we'll talk about the whatever is written on in the 3 points on top. One is the sacrificial anode system, and the other is impressed current systems, ICCP. Now, sacrificial anode system क्या होता है बेटा? अब देखो, हमने दूसरा एक लोकेशन जो बड़ा आइडियल लोकेशन था, कॉमन एग्जांपल होता है कि कहां पर बायोमेटेलिक सिचुएशन होती है शिप पे, एंड ये जिस पे इलेक्ट्रोलाइट भी प्रेजेंट हो, तो दैट इज इन द विसिनिटी ऑफ द प्रोपेलर. प्रोपेलर इज मेड ऑफ एन अलॉय. Ship's structure around it is made of mild steel. Bimetallic presence हो गया. They are immersed in sea water day in and day out. So electrolyte भी हो गया. So that's an ideal location for the corrosion to take place. अब इसमें जब तुम galvanic series देखोगे, उस galvanic series में mild steel is more susceptible than the nickel alloy, of which the your propeller may be made. तो क्या होगा? इन दोनों में आपका जो शिप का हल है, that will be playing the role of anode, and the propeller will be playing the role of cathode. So if the steel hull is going to play the role of anode, steel hull is likely to be eaten up. अब आप क्या करते हो वहां पर? उसकी विसिनिटी में आप माइल्ड स्टील से ज्यादा लेस नोबल, माइल्ड स्टील से लेस नोबल मेटल, जैसे सबसे ऊपर मैग्नीशियम था, हम मैग्नीशियम का लगा देते हैं पर होता है, उसके थोड़ा सा नीचे जिंक है लाइन में, लिस्ट में. अगर हम वहां पर जिंक की एनोड्स लगा दें शिप के हल पे, तो क्या होगा? It is the zinc and the propeller which will tend to form a galvanic cell between them. Why? Because zinc के comparison में mild steel is more noble. So the zinc will take over the role of anode, propeller will take over the role of cathode, and what will be eaten up would be the externally fitted zinc anodes. And since they are eaten up, they sacrifice themselves to save the structure of the ship. They are called as this system is called as sacrificial anode system. Why? Because the anodes sacrifice themselves to save the structure of the ship. Sacrificial anodes are metals or alloys attached to the hull that have a more anodic or less noble potential than the mild steel when they are immersed in water. These anodes supply the cathodic protection current, but will be consumed in doing so and therefore require replacement for the protection to be maintained. This system has been in use for many years. The fitting of zinc plates or zinc anodes in the way of bronze propellers and other immersed fittings being common practice, and also they are used in the tanks as well. Modern anodes are based on alloys of zinc, aluminium or magnesium, which have undergone many tests to examine their suitability. High purity zinc anodes are also being used. बेटा ये देखो फोटो, अब आगे इसमें ध्यान, ये जो चमकीली चीजें लगी हुई, ये वाली, these are the zinc anodes. I'm sure those of you who have been to the dry dock would now be able to recall these anodes, and you may have seen that these zinc anodes might have been replaced and new ones might have been fitted in the dry dock. Correct, guys?
Yes.
ठीक है बेटा. So in the process, what happens? It protects the ship's hull and they sacrifice themselves, and ठीक है, ship hull बच गया. Propeller तो वैसे ही बचा था because propeller is acting as the cathode. So the ship hull is saved. So that is called as sacrificial anode system. The second one is called as impressed current system. These systems are applicable to the protection of immersed external hull only. Please pay attention to it. Anodes हमने कहा था, yes, they were applicable for the immersed areas. They can be fitted on the outer hull under the water, or they could be used in tanks also. But this impressed current system is only to provide protection to the immersed and external hull only. They cannot be used for tanks inside and all that. The principle of the system is that a voltage difference is maintained between the hull and the fitted anodes. अब इसमें आपने क्या किया है बेटा, आपने कुछ एनोड्स लगा दी हैं, फिट कर दिए हल के साइड में, और आप उनको एक्सटर्नल करंट देते हो ताकि ये जो एनोड्स हैं इनका दे रिमेन as anodes when compared to the ship's hull, so that they keep releasing the electrons and the ship's hull is protected. So the principle of the system is that the voltage difference is maintained between the hull and the fitted anodes, which will protect the hull against corrosion, but should not overprotect, thus wasting the current. For normal operating conditions, the potential difference is maintained by means of an externally mounted silver chloride reference cell, detecting the voltage difference between itself and the hull. Diagram आएगा, मैं समझा दूं तुम्हें. An amplifier controller is used to amplify the micro range reference cell current, and it compares this with the preset protective potential value that is to be maintained. So जो आपके reference cell ने measure किया वो amplify होके it goes to a reference cell, and वो वहां पर इसको they decide as to how much current is to be supplied to the anodes. Using the amplified DC signal from the controller, a reactor controls a larger current from the ship's electrical supply that is supplied to these fitted anodes. An AC current from the electrical system would be rectified before distribution to, obviously it has to be a direct current which has to go. Originally, consumable anodes were deployed, but in recent systems, non-consumable relatively noble metals are also used. These include lead, silver, and platinum, palladium alloys, and platinized titanium anodes are also used. Let's look at this diagram. ये diagram है बेटा इसकी. It's called as ICCP system, Impressed Current Cathode Protection System. So अगर ICCP भी आता है तो यही है बेटा वो. अब ये देखिए क्या है. इन्होंने जहाज के हल में इमर्स्ड पार्ट में ये एनोड्स इंस्टॉल कर दी हैं. ठीक है, these have been installed. Okay. Now what happens is यहां पर आपकी सिल्वर या सिल्वर क्लोराइड की एक रेफरेंस सेल है. What does it do? It measures the potential difference between the reference cell and the hull. Why? Because जब ये इन दोनों का potential difference यहाँ measure कर लेगा, that is what is going to actually decide कि इन एनोड्स को करंट कितना सप्लाई करना है. अब ऑब्वियसली वो पोटेंशियल डिफरेंस डिपेंड करेगी तुम्हारा सॉल्ट कंटेंट पे, टेम्परेचर पे, सो मेनी फैक्टर्स इट विल कीप डिपेंडिंग. ओके, सो आपका एक सिल्वर क्लोराइड या सिल्वर रेफरेंस सेल है दैट मेजर्स द पोटेंशियल डिफरेंस बिटवीन द शिप्स हल एंड द रेफरेंस सेल. अब रेफरेंस सेल ने जो यहां से उसका डिफरेंस रीड किया वो उसने यहां से कंट्रोलर को पास कर दिया. कंट्रोलर compares this difference between the reference cell and the ship's potential of the ship's hull. So the difference between them is basically analyzed by the controller. Controller amplifies that signal, and that amplified signal is sent to this reactor, which is nothing but a rectifier. What is the rectifier? That converts AC into DC. So यहां से कंट्रोलर ने जो भी इसको एनालाइज किया उसका सिग्नल उसने रिएक्टर को दिया. द रिएक्टर वुड नाउ बेस्ड ऑन द इनपुट डिसाइड ऑन द सप्लाई, द करंट दैट हैज टू बी सप्लाइड टू दीज एनोड्स. सो ये जो शिप की पावर है इसको रेक्टिफाई करके based on the analysis through this channel, the supply will be given to the anodes so that ये जो electrodes fitted, now I'm using the word electrodes, ये जो electrode fitted हैं ये हमेशा anode रहे with respect to the ship's hull. इसका मतलब ये जो electrodes हैं ये हमेशा anode रहेंगी. शिप का हल जो है इसके कंपैरिजन में उसकी नोबिलिटी बढ़ जाएगी एंड देयरफॉर यहां से जो करंट है इलेक्ट्रॉन जो आप यहां से इनको दे रहे हो करंट दे रहे हो दैट इज बीइंग रिलीज टू द वाटर सेविंग द शिप्स हल फ्रॉम कोरोजन. सो दिस इज हाउ दिस आईसीसीपी वर्क्स. पहले आईसीसीपी की वर्किंग देख लो बेटा अगर इस डायग्राम में कुछ क्वेश्चन पूछने हैं तो.
सर ये तो समझ में आ गया. सर एक चीज पूछना है कि जो सैक्रिफिशियल जो होते हैं और जो आईसीसीपी सिस्टम है इसमें डिफरेंस क्या है सर? एक मिनट,
एक तो आईसीसीपी और दूसरा क्या बोला आपने?
ये सेल्फ सैक्रिफिशियल जो
अच्छा ओके सैक्रिफिशियल. बेटा एज द नेम दे पहली बात तो ये देखो आईसीसीपी इज ओनली फॉर एक्सटर्नल इमर्स्ड हल.
हाँ सर ये चीज भी पूछना है कि ये इंटरनल में क्यों यूज नहीं कर सकते?
बिकॉज इंटरनल में इसलिए नहीं करते बेटा क्योंकि जो पानी होगा ना तुम्हारा जो अंदर में टैंक्स में होगा राइट that is again connected to the ship's hull only ना मतलब basically उसके bulkheads and everything is interconnected right?
Yes sir.
वहां तो आपने जो इलेक्ट्रॉन्स छोड़ दिए वो सी वाटर में चले गए राइट? इसमें जो भी कुछ रिलीज करोगे दैट विल बी कंटेन्ड विद इन द शिप स्ट्रक्चर ओनली ना बच्चे. सो जो भी अंदर में सेल बनेगा आप हो सकता है ये बल्कहेड प्रोटेक्ट कर लो दूसरे बल्कहेड पे कोरोजन होगा बिकॉज एवरीथिंग इज हैपनिंग विद इन द शिप राइट नाउ राइट.
ओके
तो दिस इज ओनली फॉर द एक्सटर्नल हल एंड दैट टू इमर्स्ड जो कि पानी में डूबा हुआ है पानी के ऊपर वाले पे काम नहीं करेगा राइट.
ओके.
नंबर 2 जो सैक्रिफिशियल एनोड सिस्टम था वहां पर वो जो एनोड है वो जो इलेक्ट्रोड आपने लगाई हुई है जिंक की मैं कभी इलेक्ट्रोड वर्ड यूज कर रहा हूं कभी फिर उनको एनोड कर रहा हूं जो आपने एनोड जिंक की लगाई जिंक इलेक्ट्रोलिटिक सीरीज में माइल्ड स्टील से कम नोबल है दैट मींस इट्स लेस नोबल एंड मोर ससेप्टेबल टू कोरोजन राइट.
ओके.
तो जब वो माइल्ड स्टील के साथ आपने उसको लगा दिया तो अगर उन दोनों में से किसी को एनोड बनना होगा तो आपका जो जिंक इलेक्ट्रोड्स हैं वो एनोड का रोल प्ले करेंगी राइट. और वेस्टेज किसकी होगी? एनोड की राइट. तो क्या होगा धीरे 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 ये जिंक जो आपने जिंक की एनोड लगाई थी ये पूरी की पूरी आपकी खत्म हो जाएगी. तो अगली ड्राई डॉक में हो सकता है यू विल हैव टू रिप्लेस देम ऑल ओवर अगेन. सो उसने तो अपने आप को सैक्रिफाइस कर दिया आपने उसको फिट करके छोड़ दिया उसके बाद अपने आप पानी के उसके बीच में अपने आप सारी चीजें हो रही है एंड एज लॉन्ग एज द जिंक एनोड का कुछ भी रिमेन रहेगा इट विल कीप एक्टिंग एज एनोड. जिस दिन वो खत्म हो जाएगी सपोज you don't go to dry dock for 10 years and zinc anodes have all been eaten up now your hull will be impacted right.
Okay.
On the other hand this ICCP में ये जो एनोड्स हैं ये आपने हल में एक तरह से परमानेंट एनोड्स पहले इलेक्ट्रोड वर्ड यूज करते हैं आपने ये कुछ इलेक्ट्रोड्स स्पेशली हल में कनेक्ट कर दिए हैं राइट. ओके ठीक है. अब इन इलेक्ट्रोड्स को अगर मैं शिप से कोई करंट की सप्लाई नहीं दूं ओके देन it is not going to provide any protection to your ship. Why? Because these electrodes will become anodes only when you supply them the voltage, right? Otherwise they are simple anode, they are simple electrodes, right?
तो सर मतलब इनका जो ये जो वो होता है मतलब हर ड्राई डॉक में इसको चेंज करने की जरूरत नहीं है.
नहीं देखो ऐसा है पहले आप अभी स्लाइड में आपने पढ़ा था कि आजकल जो इनको लगा रहे हैं दे हैव अ ह्यूज लाइफ टाइम बिकॉज दे आर नॉट सपोज टू बी बेसिकली वेस्टेड बिकॉज आपके इलेक्ट्रॉन्स तो आपने सप्लाई किए वो लूज हो रहे हैं ना यहाँ से राइट. जब शुरू में जब ये नया सिस्टम आया था तब बेटे यहाँ पर जो लगाते थे इलेक्ट्रोड्स they were eaten up but they were not eaten up at the same rate as the sacrificial anodes right.
Okay. समझ गया.
But nowadays, yes, more research has been done, and now the anodes used in ICCP are, you can say, more or less permanent. ठीक है. जब शुरू में सिस्टम आया था उस टाइम इसकी एनोड्स भी, अब उस टाइम वो एनोड्स क्यों ईटर्न अप हो रही थी? Was it that this system of supplying current was not perfect? Whatever may be the reason, or maybe the metals used here were more susceptible, and they, you know, because of their higher susceptibility to corrosion, they started getting eaten up as anodes, right? So there could have been various reasons for that. But the system of today, where this referencing, measurement of the difference, controller playing its role, deciding what to supply, reactor precisely supplying what it is expected to supply, with all this happening, and at the same time good alloys being used as metals. Now the present day anodes in ICCP have a huge life, and practically you can say they are permanent electrodes, right beta?
Okay sir, समझ गया.
समझ गए? ठीक है. Okay guys, we are almost halfway through. 52 slides हैं हमारी, 23 हो गई हैं. So we can take a break of 15 minutes. So 52, 55, 12:55 we resume from here beta. Let's take a break up to 12:55. Okay, चलो.
Okay, sir.
गुड आफ्टरनून सर। सब ठीक सर, आप बताइए कैसे हैं? बस हम जयपुर आ गए वापस। आ जाए सर। अच्छा 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 सर। और ओके 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 ओके। मैम की तबीयत कैसी है? अब ठीक है। और सर? अच्छा, अभी मैंने कंपनी से बात की थी ऑफिस में फोन पे। हाँ सर। तो वो बोल रहे हैं कि मेरे को भी ना वो जो आपका जो वैलिड का अपडेट कराना पड़ेगा सर्टिफिकेट। अच्छा, कौन सा? मास्टर्स का सीओसी। ओके 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 ओके। वो कह रहे हैं कि वहाँ पे एमसा ने पकड़ लिया किसी क्लास को क्या। अच्छा, तो इससे कह रहे हैं कि हम चाहते हैं कि आपका अपडेट करा। ठीक है सर, करा लीजिए। तो मैं तो सिर्फ पूछ रहा था वो मॉड्यूलर कोर्स को कैसे जाते हैं, किस वेबसाइट पे जाते हैं? हाँ सर, डीजी की सर मैं आपको थोड़ी देर में फ़ोन करूँ, मेरी एक बार क्लास चल रही है, 5-10 मिनट में कॉल करूँ? हाँ तो आराम से कर, कोई जल्दी नहीं है, मैं कल मॉर्निंग से ना स्टार्ट करने वाला हूँ। ठीक है ठीक है, कभी भी कर सकते हैं ना, कोई ऐसा थोड़ी है कि कोई समय होता है। नहीं सर, एक्चुअल में वो कहीं से बुक करना पड़ेगा ना कॉलेज से आपको। नहीं, पहले तो मैं वो इशू नहीं है सर, आप कॉलेज पहले बुक कर लो, वो तो साथ आप उसमें तो कोई इशू ही नहीं है, वो तो आप है ना उसको बैठे रहो, आगे फॉरवर्ड करते रहो, कॉलेज चलते चलते भी तो नॉट एन इशू, उसका कोई इशू नहीं है। कॉलेज का नहीं, पहले मैं टीचर्स को भी क्या है ना यार, मैं मेरा वहाँ पे ना मेरा सारा का सारा ये तो डेटा ठीक है। नहीं नहीं, वो इशू नहीं है सर, सर्टिफिकेट डीजी से इशू होगा, वो तो आपको करना ही है एसेंशियल है। कॉलेज पहले बुक कर लो क्योंकि कॉलेज मिलते नहीं है, बेसिक थिंग इज दैट। तो अच्छा, तो सर ठीक है, आप डीजी का कर लेना, तो मैं आपको बता दूंगा अभी। मैं तो ये फरीदाबाद वाला बुक कराऊंगा, फरीदाबाद में। हाँ, फरीदाबाद में जो कॉलेज है जो ऑनलाइन कराना है। हाँ 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 हाँ, वहीं से करूँगा। ठीक है सर, मैं आपको शाम को बता देता हूँ कैसे सब पढ़ना है, ठीक है ना सर, थोड़ा सा है ना। हाँ ओके सर। अगर आ सकता है तो और बेटर रहेगा। हाँ सर, मैं अभी थोड़ी देर में कॉल करता हूँ, मेरी स्टेबिलिटी की क्लास चल रही है ना सर। ओके ओके ओके।
Okay, beta. Shall we run through the remaining slides if it's okay with you? Guys, shall we continue, beta?
Yes, sir.
Yes, sir.
Shall. Let's continue because I think we should be able to close comfortably, no issues. Okay, then we have the last method of containing or minimizing the risk of corrosion is the protective coating, that is the paints. Now, paints intended to protect against the corrosion consist of basically few components. One is called the pigment, that is dissolved or dispersed in the liquid, and the liquid is called as the vehicle. So there are two parts to the paint, the pigment and the vehicle. When it is spread out thinly, the vehicle changes in time to an adherent dry film. Basically a dry film which sticks. So the vehicle dries out, pigment remains, and it becomes a binding film, and that provides the coating. The drying of the vehicle may take place through one of the following processes. The drying and the coat being formed, adhesive protective being formed, could be because of one of the following ways. When the vehicle consists of solid resinous material dissolved in a volatile solvent. So that means here the vehicle is a volatile solvent. Though since it's volatile, obviously it will evaporate after application and exposed to environment. And once the vehicle evaporates, being volatile, what it will leave would be a dry film, which will stick to the surface. Or some liquids, some vehicles like linseed oil, etc. When they come in contact with the atmosphere, they chemically react with the surrounding air and thus form a solid film. So in some cases, the vehicle may evaporate completely. In the other case, it may react with the air to form a solid product. A chemical reaction may occur between the constituents of the vehicle and after the application. Now, in some paints, the reaction may take place within the constituents of the paint itself. Please appreciate this. In the second one, it was a reaction between the paint and the air. In the last one, it is the reaction within the constituents of the paint, and that reaction results into a dry film. These are your 2-pack paints, like the epoxy paints that we have started using on board nowadays. So the last one are the 2-pack paints that we are talking about. So the drying may take place because of the vehicle being volatile, or the paint constituents reacting with the air, or the paint constituents reacting with each other, resulting into a dry film. Any of these processes could have been used in the paint so that the drying takes place and our adhesive film is produced. Now it's very essential that for painting, the most important part of the painting is the surface preparation, because if the surface is not prepared, then obviously there are issues. A good surface preparation is essential to successful painting. The primary cause of many paint failures being the inadequacy of the initial metal preparation or the surface preparation. The most common methods employed for preparing the steel surfaces for painting are, they could be blast cleaning, they could be pickling, flame cleaning, preparation by hand, जो हम अपने वायर ब्रश वगैरह चिपिंग और वायर ब्रश से करते हैं, high pressure water ballasting. So any of these could be there. I'm sure all these terms are familiar to you. Blast cleaning, we all know. It could be sand blasting, grit blasting, water blasting, any of those things. Pickling is when you dip the metal into an acid or some chemical so that the rust gets cleared off. That is called as pickling. Then cleaning with flame and preparation by hand and high pressure water blasting. So these are the various methods which could be deployed for cleaning the metal of rust and impurities before it's applied with the paint coating. Now, When you prepare the surface depending on the extent of preparation, basically to what degree the rust has been removed before the application of the paint, the surface readiness is expressed as per certain standards. Now, there are different organizations which have come out with these standards. One of them is SSPC standards, Society for Protective Coatings Standards. Other is NACE, National Association of Corrosion Engineers International Standards. And the third are the Swedish standards. These are the commonly used standards to describe the nature of preparation. What is the degree of surface preparation? How do we describe it? So any of these standards could be used. Now, all these standards are basically talking in the same language, dividing the preparation into similar categories. Only thing is the notation used being is different for each standard. Now, one level of preparation could be a simple brush off. And what does brush off mean? Loose mill scales are removed. Loose rust and foreign particles are removed. Now, if that is the only level of preparation before the application of the paint, then you say the standard of preparation is brush off. अब brush off को describe करने के लिए NACE का कोड कुछ और होगा, Swedish standards का कुछ और होगा, SSPC का कुछ और होगा, but in each case the level of preparation would then be brush off, which will mean loose rust and foreign particles are removed. Another level of preparation could be commercial, in which mill scale rust and foreign particles are substantially removed. Okay, and gray metal is visible. ऊपर वाले में आपने loose mill scale, loose rust and foreign particles are removed, but gray metal will not be visible. In the commercial one, it's slightly more extensive cleaning, more extensive preparation compared to brush off. And here they are to a large extent removed. उधर तो सिर्फ loose निकाले थे. यहाँ पर it is whether loose or sticking, most of it is removed, substantially removed, not most of it, substantially removed, and gray metal is visible. So that is called as commercial level of preparation. Third is near white metal, which means mill scale, rust and foreign particles are removed to the extent. So there in the previous one, it was substantially removed. Here they are removed to the extent that only the traces remain in the form of spots or stripes. आपने पूरा निकाल दिया, जो बचा है सिर्फ that may be in the form of some stripes or some spots. The cleaned surface will show varying shades of gray, and that preparation level is called as near white metal. And the last level of preparation could be categorized as white metal. That means visible mill scale, rust and foreign particles are entirely removed. The cleaned surface should have a uniform metallic color, but may show varying shades of gray when viewed at different angles. So obviously of these, white metal is the most extensive cleaning. Brush off is the first level of cleaning, and the level keeps increasing from brush off to commercial to near white metal and white metal. Basically मोटी जो categorization है वो ये 4 categories में आती हैं. As I told you, I've been saying again, since different organizations have come out with their own classification of surface preparation, so the codes assigned may be slightly different. Whilst each standard may differ slightly in requirements, थोड़ा 19-20 का फर्क होगा. And terminology, the following cross-reference chart indicates the close approximation. It's not the precise correlationship, but nearly approximate to each other. See, when you talk of brush off, NAC mein they will call it as number 4. SSPC mein they will call it as SP7, and Swedish standards would be SA1. So if you say Swedish standard SA1, though it will be defined separately, but it will be talking of brush off levels. If you talk of Swedish standard 2, SA2, which is nearly equal to SP6 for SSPC and number 3 for NACE, that will be your commercial level. Swedish standard 2.5 is near white metal, and Swedish standard 3 is your white metal. तो ये देखिए, NaCe goes from 4 to 3 to 2 to 1. SSPC goes from SP7 to SP6 to SP10 and SP5. So these are varying codes that have been assigned, but उनका nomenclature basically, अगर कोई एक Swedish SA1 की क्या preparation level है, तो basically they'll be very close to brush off. So आप brush off वाले define कर दोगे. ऐसे Swedish SA2 की बात करेगा तो commercial वाला जो भी हमने देखा previous slide में वो define कर देंगे. SA 2.5 बोलेगा तो near white metal वाला आ जाएगा. And अगर Swedish standard SA3 आए, ये मैं इसलिए आपको कह रहा हूँ कि ये SA 2.5, SA2 एक दो बार आपके पेपर में आए हुए हैं. And that is the whole idea of basically emphasizing upon this slide better. Now, blast cleaning preparation guide under Swedish standard, description when viewed with naked eye. SA1. Now SA1 क्या होगा? वही आपका कौन सा? Brush off. Brush off means light blast cleaning, loose mill scale, rust and foreign matter must be removed. SA2, thorough blast cleaning, almost all mill scale, rust and foreign metal must be removed. Finally, the surface is cleaned with vacuum cleaner, clean dry compressed air or a clean dry brush. So ये SA2 की actual description है, but if you see, it is very close to commercial. SA 2.5 will be very close to near white metal. Very thorough blast cleaning. Mill scale, rust and foreign matter must be removed to the extent that only traces remaining are slight stains in the form of spots or stripes. Finally, the surface is cleaned with vacuum cleaner, clean dry compressed air or clean dry brush. And SA3 की अगर exam में आती है तो you will be basically describing this way. It is nearly your white metal. Blast cleaning to pure metal. Mill scale, rust and foreign matter must be removed completely. Finally, the surface is cleaned with vacuum cleaner, dry compressed air or a clean dry brush, and that standard of preparation will be SA3. So surface preparation which holds the key to success of paint on a surface, that surface preparation is described through various standards. Most often आपने जहाज में Swedish standard सुने होंगे, SA1, SA2, SA 2.5 and SA3. ये तीनों बेटा याद कर लेना, ये एग्जाम में एक दो बार पूछा गया हुआ है. आज तक दूसरे वाले SP6, SP7 पूछा नहीं गया है, बट कुछ नहीं पता हमारे लोगों का, तो उनको कोरिलेशन थोड़ी देख लेना between NaCe standards and SSPC standards with respect to Swedish ones. Now we come to especially the paint systems on ships. Now we all are familiar with primer paint, चाहे वो red lead हो, which is the most commonly used primer, or other primers, right? Zinc chromate primer या कोई भी primer हो. So what is a primer paint? It's basically a temporary protection. After the steel is blast cleaned, it is desirable to protect the material against rusting until final paint is applied. So it's a temporary coating. What must be taken care of is that the primer is compatible with any subsequent paint finish to be applied. So जो primer आप लगा रहे हो, it should be such that it is suitable for the final coating that is to be applied. ये नहीं है कि red lead लगा दिया उसके बाद आपने zinc paint करने शुरू कर दिए, नहीं. For zinc, there will be a separate primer. For rubberized, there may be a separate primer. For epoxy, there will be epoxy primer. So the primer has to be compatible with the subsequent finish that is to be used. The paint system applied to any part of the ship will be dictated by environment to which that part or structure is exposed. Obviously, कहाँ पर कौन सा paint लगाना है तो वो depend करेगा कि वो part किस type के environment को exposed है, because the paint should be basically providing protection against that particular environment. The painting of external ship structure has been divided into 3 regions. आजकल हालांकि इनके differences कम होते जा रहे हैं, but yes, traditionally they are divided into 3 regions. One is below the water line where the plates are continually immersed in sea water below the line. बेटा मैं 1 मिनट मेरा बैटरी लो हो गई 1 सेकंड में जरा चार्जर लगा लूं 1 सेकंड दे दो मुझे. Okay, so one could be the light water line which is continuously immersed underwater, so that could be one part of it. Okay, other could be the boot top region, which is sometimes outside water, sometimes underwater, depending on the draft of the ship, so that could be another thing. And the last is the one top side one which is above the water, including the superstructures. आजकल बेटा बूट टॉप रीजन और बिलो द वाटर लाइन रीजन की लाइनें मोस्टली ब्लर हो गई हैं. पहले ये एक टाइम होता था कि ये 3 पार्ट्स में उसको डिवाइड किया जाता था. Now that tougher paints are used for ship's bottom, the distinction between regions need not be so well defined. आपने देखा होगा काफी जहाजों में नीचे से लेकर ऊपर तक एपॉक्सी पेंट कर देते हैं. So maybe the regions are now, because you have now much tougher paints, and if only thing is they're expensive, if the company wants to spend that money, then obviously that could also be done. Internally, by far the greatest problem is the provision of coating for various liquid cargo and salt water tanks. Obviously wahan ke coating has to be, you have to be sensitive to the coating. Why? Because you'll be carrying maybe seawater or different types of cargo in those tanks. Now below the water line, that is the ship's bottom, has priming coat of corrosion inhibiting paint, and that is followed by anti-fouling paint. We all know this, that ship ki bottom mein, to prevent the marine growth barnacles, we use this anti-fouling paint. Of course, now anti-fouling convention is also there, but the paint has to be suitable and meeting the requirements of the convention. But yes, anti-fouling paints are still being used. Iron alloy immersed in sodium chloride solution having the necessary supply of dissolved oxygen gives rise to corrosion cells with caustic soda produced at the cathodes. Thus, paints used for steel in seawater are required to resist alkaline conditions. Also, paint should have a good electrical resistance so that the flow of corrosion currents between the steel and seawater is limited. So that is the requirement of the paint below the water line. They should be alkaline in nature, and they should be non-conducting or practically insulating as far as the flow of current is concerned. These requirements make the standard non-marine structural steel primer like red lead unsuitable for the ship below the water line. Suitable corrosion inhibiting paints for ships' bottoms are pitch or bitumen type, chlorinated rubber, coal tar, epoxy resin, or vinyl resin paints. These are some of the types of paints which are suitable for the underwater hull of the vessel. The anti-fouling paints may be applied after the corrosion inhibiting paint coating, obviously, because anti-fouling is not to prevent against corrosion. It is to prevent the growth of prevent the marine growth on the hull. Anti-fouling paint should not come into direct contact with the steel hull. Kyun? Because they are toxic, they have chemicals, and they may actually trigger the corrosion. So anti-fouling paint should not be used on bare metal. They will be used on top of corrosion inhibiting paints. Then we have the waterline or boot topping region. Generally, modern practice requires complete paint system for hull above the waterline. It's usually the same from waterline to the top. पहले अलग होता था, अब तो more or less same है. This may be based on vinyl or alkyd resins or polyurethane resin paints. So that is your boot top region, made of polyurethane resin paints. एपॉक्सी भी चल रहे हैं शिप साइड में, ऐसी बात नहीं है एपॉक्सी नहीं चल रहा है, दे आर लिटिल मोर एक्सपेंसिव, बट यस नाउ शिप ओनर्स हैव स्टार्टेड गोइंग फॉर एपॉक्सी ऑन दिस पार्ट ऑफ द शिप. Superstructure paints, red lead or zinc chromate based primers depending on the surface. White finishing paints are then used extensively for superstructures. We know these are usually oleoresinous or alkyd paints and may be based on non-yellowing oils, because you don't want the paint white to become yellow after some time. Linseed oil based paints that yellow on exposing being avoided on the modern ships. Non-yellowing paints you prefer. Where aluminium alloy superstructures are fitted, under no circumstance should lead-based paints be applied on aluminium superstructures. So that I think we all know. Zinc chromate paints are generally supplied for application to aluminium. Cargo and ballast tanks, you have severe corrosion conditions that can occur there, and also you carry these things at different temperatures. These tanks are also, they get impacted because you wash them with hot and cold water. So all that has to be taken into consideration before the ship owner decides on the coating to be used for cargo and ballast tanks. Tankers carrying white oil cargoes suffer more general corrosion than those carrying crude oil. Why? Because crude oil leaves a film, thick film on the tank surface, providing some protecting against the corrosion. The latter type may, however, experience severe local pitting corrosion due to non-uniformity of the deposited film and subsequent corrosion of any bare plate when seawater ballast is carried in those tanks. Of course, these instances are now reducing because you have now segregated ballast systems. So this tendency of carrying ballast into the oil tanks is of course now obsolete unless it's warranted by rough weather or something. Epoxy resin paints are used extensively within these tanks, and vinyl resin and zinc rich coating may also be used. That's on the cargo and ballast tanks. बेटा ये आपका क्वेश्चन आया होगा आप जब पास पेपर देखोगे. Describe the paint structure on the ship. तो बेसिकली आपको क्या करना है, आपका आधा आंसर इस बात पे जाएगा कि it will depend upon the place and the environment to which that surface is exposed, and then you will basically stock of ship's outer hull, then superstructure, ship's upper part of the deck and all that, then water ballast tanks, and then cargo tanks. All those you'll talk separately depending on kitne marks ka paper hai, and you'll accordingly fill up the sheet. ये जो वेटेड सरफेस एरिया है बेटा, ये आपके सिलेबस में स्पेशली मेंशन्ड और एक दो बार पेपर में आया है. This term has come in papers a few times, wetted surface area. For a vessel floating at a given water line, the total area of its outer surface in contact with the surrounding water is known as its wetted surface area. जिसको काफी लोग मुझे water plane area बोलते रहते हैं ना, मुझे बड़ा गुस्सा आता है उस पर. जिस लोग सोचते हैं ये वाली चीज वाटर प्लेन एरिया है, वाटर प्लेन एरिया ये नहीं है. ये जो पूरा का पूरा सरफेस जो है पानी के नीचे, जो कि शिप का पानी के कांटेक्ट में, दैट मींस अंडर वाटर शिप साइड एरिया, कील, all that added together becomes the wetted surface area. That means the surface of the ship's hull that is made wet by the seawater in which it is immersed, that area is called as wetted surface area. The total wetted surface area for ship depends on its type, because uska form jo hai block coefficient वगैरह पे depend करेगा. So it will depend upon the size of the ship and the type of the ship. Ship's hull fouling increases fuel consumption. Of course we know अगर hull पे fouling होगी तो speed भी कम होगी, fuel consumption बढ़ेगा. Ship owners coat the wetted surface with such paint which prevents the formation of marine growth, like your anti-fouling paints. Now, how do we calculate this wetted surface area? इसका कोई calculated हमारा derived formula नहीं है. इसका एक empirical formula जो कि experience के based पे, which can give you estimated water wetted surface area. एक formula तो ये है बेटा. Wetted surface area is CWS square root of V into L, where V is the volume of displacement at that water line. CWS is the wetted surface coefficient of the vessel. The wetted surface coefficient is typically in the region between 2.6 to 2.9. ये बेटा estimate करने के लिए, this is no precise thing. Such formulae are called as empirical formulae. Empirical formulae क्या होता है? जिनकी कोई derivation नहीं होती. वो सिर्फ आपने एक डेटा कलेक्ट किया है and then you have tried based on that analysis, you have tried to come out with some formula which will be best suited to give you the results. They are called as empirical formulae, and wetted surface area formula is also such empirical formula, has no derivation to support it. But then this is one formula, और ये कई बार एग्जाम में आ चुका है बेटा, मैं इसलिए आपसे कह रहा हूँ. Some people instead of volume prefer to use displacement, and in that case this formula stands modified to this 2.58 square root of displacement into length. Okay, so ये इन्होंने थोड़ा सा मॉडिफाई कर दिया उसको, और वही फॉर्मूला है, सेम फॉर्मूला, ओनली थिंग इज इट हैज बीन मॉडिफाइड टू रिप्लेस दिस v बाय w. सो ये दोनों के दोनों फॉर्मूले आप याद कर लेना, ये लिखने पड़ सकते हैं आपको एग्जाम में. ये एग्जाम में एक दो बार आप देखोगे अगर नीचे थ्योरी वालों में, wetted surface, write a short note on wetted surface area, describe wetted surface area, इस तरह करके आपके ये short notes में आया हुआ है बेटा. And I think now we come to the last part of this particular chapter. This is again very clearly mentioned in your syllabus, MSDS, Material Safety Data Sheet. It's basically a sheet released by the manufacturer, which basically lists down the characteristics of the product, the precautions to be taken. It's any IMO number or whatever. All those things are contained in that sheet. And why it has come under this topic of corrosion? Because of the paints. You should have the MSDS. Before you use the paints, you should refer to its MSDS so that you know what are the dangers involved with that particular paint. MSDS is an important component of product stewardship and occupational safety and health. Stewardship means product ownership. It's an important component of product ownership and occupational safety and health. Product stewardship is an environmental management strategy. That means whoever designs, produces, sells, or uses a product takes responsibility for minimizing the product's environmental impact throughout all stages of product's life cycle, including end of life cycle management. So product stewardship puts onus on everybody, and we as ships operators, being the users of those products, it puts responsibility on us also to make sure that we take responsibility for minimizing the product's environmental impact. इसीलिए तुम्हारा बेटा ये जो anti-fouling convention आया है वो भी इसी कारण से आया है. So that is to minimize the impact on the environment and at all stages of the product, including dealing with the product when it comes to end of its life cycle. So that means disposition of such waste material, how you are going to handle that also becomes part of the product stewardship. It is intended to provide workers what MSDS. MSDS is intended to provide workers and emergency personnel with procedures for handling or working with that substance in a safe manner. It includes information such as physical data, toxicity, health effects, first aid, reactivity, storage, disposal, protective equipment, and spill handling processes. MSDS formats can vary. Now, this is important. MSDS formats can vary from source to source within a country, depending on the national requirements. There is also a duty to properly label substances on the basis of physical, chemical, health, and on environmental risk. MSDS for a substance is not now please pay attention to this important point. MSDS is not primarily intended for use by the general consumer. ये general consumer के लिए नहीं है. focusing instead on the hazards of working with the material in an occupational setting. अब जनरल कंज्यूमर का मतलब ये नहीं है कल को तुम कहो आई वाज द कंज्यूमर ऑफ द पेंट, व्हाई शुड आई बी इंटरेस्टेड विद MSDS? नो, you are basically using that paint in your occupational setting. So therefore, do not get confused between confused and treat yourself as a general consumer. But MSDS is for a substance is not primarily intended for use by a general consumer, but it focuses on the hazards of working with the material in occupational setting. तो अगर मैं घर के लिए पेंट लेके आता हूं तो मैं MSDS नहीं मांगूंगा, because that is a general consumer, one small thing which you picked up. But when you are using on the ship, then you are not a general consumer, you are using it in the occupational setting. In some jurisdictions, the MSDS is required to state the chemical's risks, safety and effect on environment. So थोड़ा सा फॉर्मेट जो है MSDS का country to country vary हो सकता है. It is important to use an MSDS specific both country and supplier, as the same product can have different formulations in different countries. The formulation and hazard of the product using a generic name may vary between manufacturers in the same country. So you have to be careful. That means, in other words, if we want to sum it up, we say the MSDS should be specific to the product that I am using, released by the manufacturer of that particular product. Then it will take care of this issue completely. ये जो MSDS का मैंने एक सैंपल निकाला हुआ है और आप इसको देखो, यहाँ पर एशियन पेंट्स का MSDS की शीट है, इसके कुछ सेक्शंस हैं. सेक्शन 1 में इन्होंने क्या डाला हुआ है, मटेरियल आइडेंटिफिकेशन एंड यूज, मटेरियल नेम, मैन्युफैक्चरर्स नेम, सप्लायर्स नेम, एड्रेस डिटेल्स. Then you have section 2, hazardous ingredients of the material. Then section 3, physical data for the material. So this is the MSDS from Asian Paints, you know. Then fire and explosion hazard of the material. Then reactivity data. Then toxicological properties of the material, its toxicity. Then you have preventive measures, that in case of any leakage or otherwise, what should be the preventive measures. Then first aid measures in case it comes in contact with the eye, contact with the skin. If you consume it, ingestion, and if there is inhalation, if you breathe in the fumes, then what are the first aid measures that are required? And lastly, you have date of preparation of MSDS. And please read the technical, the section 10, the disclaimer. Information contained in this MSDS is believed to be reliable and given in good faith, but no representation, guarantee or warranties of any kind are made as to its accuracy, suitability for a particular application or results to be obtained from them. The user of this material decides what safety measures are necessary to safely use this material, either alone or in combination with other materials. Asian Paints Industries Coating Limited makes no warranties expressed or implied in respect of adequacy of this document for any particular purpose. Now they have very smartly put a disclaimer, but this disclaimer can save them only partially. Why? Because whatever they have put here, if that is proven to be wrong, then of course the disclaimer will become null and void. Something they have missed out from here does not mean that does not apply. So that is where the user should be very careful. So what does it basically, why I have read out this disclaimer is that even if you're referring to MSDS, you still need to be always aware of the fact that there could be something beyond MSDS which may require extra diligence on your part. So when you use such materials, yes, MSDS is a very, very vital document to refer to, and you must refer to it to the MSDS of the substance being used. But at the same time, please be wary of the fact that there may be something which is missed out in the MSDS. And if you can identify that before use, then seek the information. If you have missed out, at least be aware of the fact that there could be something. So you need to be extra careful when using such products. दैट क्लियर बेटा? ठीक है भाई लोगों?
ठीक है सर।
यस सर, थैंक यू सर।
ओके
सर ये स्लाइड ग्रुप में ये भेज देंगे सर, ये प्लीज ये वाली फाइल
भेज देंगे बेटा, क्यों नहीं भेजेंगे, मैंने क्या करना है इसका। ठीक है, और जरा अब आपके 3 टॉपिक हो गए हैं, एक टॉपिक रहता है हार्मोनाइज सर्विस सिस्टम, बाकी आपका कंस्ट्रक्शन का सारा पार्ट हो गया है बेटा। तो यू कैन नाउ स्टार्ट प्रिपेयरिंग। और बेटा पास पेपर के क्वेश्चंस लाने शुरू कर दो उसमें क्या नाम है क्लास में। मैंने लास्ट टाइम शायद आपको कहा था कि लास्ट के 10-15 मिनट हम लोग इस चीज़ में लगा सकते हैं। So you need to start going through the past papers, come with your doubts to the class. और दूसरी एक और बात है, मैंने लास्ट टाइम भी कहा था, again repeating, please keep handy in every class by default the stability particulars. We'll be using them for in any case for GZ curve. So GZ curve के लिए तो मुझे चाहिए ही। और अगर आपके पास बेटा हार्ड कॉपी नहीं है, you must get used to using a hard copy. So don't rely on the soft copy in your phone or laptop. अगर आपके पास हार्ड कॉपी नहीं है तो बेटा जो सॉफ्ट कॉपी उसको ले जाओ, उसको एक प्रिंट निकलवा के उसको स्पाइरल बाइंड करा लो। एटलीस्ट क्लास में उसको यूज करना, तुम्हारे हित के लिए है बात। सो प्लीज यूज अ हार्ड कॉपी रादर देन यू बैंकिंग ऑन अ सेफ सॉफ्ट कॉपी। ठीक है, चलो बेटा, देन डन फॉर द डे, टेक केयर, आई विल साइन आउट देन। ओके,
थैंक यू सर।
ओके बेटा, बाय।